Welcome everyone. My name is Tony Burke, and today we're going to talk about Type 5 routes with EVPN VXLAN. So one of the questions, I saw this question on Reddit recently, the networking subreddit, and I've seen this kind of a confusion throughout the industry about what Type 5 routes are with EVPN VXLAN. So this video is going to cover that. So our example topology here is going to be a pretty standard leaf spine topology. There's no multi-homing on the hosts. The hosts are connected into leaf 1 and into leaf 4. And that's just how we're going to demonstrate all this. So let's talk about EVPN route types first. So EVPN for unicast is introduced, well, for one thing, EVPN is an address family for multi-protocol BGP or MPBGP. There are several route types depending on the information being shared. So BGP is about sharing information, and we encapsulate that information into different types. The EVPN address family is what we use for EVPN VXLAN to share endpoint reachability, external network reachability, flood domains, etc. And that's all done with the various route types. For unicast, there are 5 route types. There's type 1, type 2, type 3, type 4, type 5. Anything from type 6 and above is for multicast, and that's beyond the purview of this particular presentation. So the type 1 route is used for ESI, that's EVPN all active. That's an alternative to MLAG or VPC or whatever. Type 2 is endpoint reachability, either MAC or MAC IP. We'll get into that in a little bit here. Type 3 is used to determine which VTEPs we're going to send flood frames to if we're doing ingress replication, also known as head-end replication, HER. Type 4 is Ethernet segment route. Again, it's part of the EVPN all active. I'll probably do a separate video on what the differences between type 1 and type 4 are. And then we have the EVPN type 5 route, which is the IP prefix route, which is the subject of this conversation. So what is a type 5 route in EVPN VXLAN, and why do we have it? It's a route used for both internal subnet reachability as well as external subnet reachability. Internally, we use it to find silent hosts, and we'll get into how we do that. For external reachability, a border leaf will connect to an outside world, an outside world. I got a mistake here. Let me just fix this real quick. I'm sure there's more than one spelling mistake or grammatical mistake, and but I'll catch them here. But for external reachability, a border leaf will connect to an outside router and learn external routes. And then the type 5 route will disseminate those routes to the other leafs. And I'm going to show you examples of both. So, and sometimes it's a little bit confusing about what the difference between a type 2 and a type 5 route is, because they're both network routes. They both deal with IP addresses. A type 2 route is used to advertise endpoint reachability. So it's not only an IP address, but it also it will advertise MAC addresses. And it's a MAC address and a single host address, either IPv4 or IPv6. So IPv4, it would be a /32. IPv6, it's a host route /128. A type 5 route is used to advertise network prefixes. So it's got to be bigger than a /32 or bigger than a 128 in order to count there. So these are looking for networks, not hosts. Type 2 is for hosts. Type 5 is for networks. So here's the topology again that we're looking at. We're doing a fairly standard eBGP scenario where the spines all have their own AS number. So the spines share an AS 65001, and then each leaf has their own ASN. We're not doing any multi-homing, so we're not doing, this is, by the way, this is all Arista. So this is running in Container Lab. If you want to build this topology and work with this style of topology, and you want to be able to do it in less than 30 minutes, I do have a separate project called Autobox, which is a set of instructions to build yourself a VM. So if you can create a virtual machine that has 4 virtual CPUs and 16 gigs of RAM, you can build this exact topology and run these exact scenarios. It's called the Autobox. I'll put the link to the GitHub repository that has the instructions in the notes of the video. But just a little background about that. So in the logical diagram is we are doing symmetric IRB, which means we are routing and switching in EVPN VXLAN. We have 2 L2 VNIs, one's on VLAN 10, one's on VLAN 20, And then we have an L3 VNI with a VRF blue called blue that's going to route between the two. And the first scenario we're going to go over is the type 5 route internally. So let's take a scenario here. Host 1 just comes online and then sends out a packet. Now, whether it's in the local subnet or the external subnet, Leaf 1 will learn this MAC address just like it normally does. This is standard. So far, this is standard layer 2 behavior. But it also learns the IP address, and it's going to generate what's called a type 2 route, a MAC route and a MAC IP route. So it's actually creating two type 2 routes. The MAC route just has the MAC address. The MAC IP route has the MAC and IP, which is used to populate the ARP tables of the other Anycast gateways. So they're going to go over to Leaf 4 and to the other leaves as well, but it's going to go to Leaf 4 in this case. So we've got these two. We've got Leaf 1 and Leaf 2. And Leaf 4 is populated with the MAC address, and we didn't populate with the IP address, but that's okay. Oh, I see a bug here. Maybe this will be the preliminary thing here. Yeah, we'll do that. Okay. So yeah, I just had to fix the IP address. I noticed that was wrong. So right now the forwarding tables are empty. With symmetric IRB, we have the layer 2 table, which will get propagated to the other leaves that have that VLAN on it, or that MAC VRF. It's a VNI, but we're just going to say VLAN. And they also have a layer 3 forwarding table. So we learn the MAC address, and we say in case we have a host locally that needs to know that MAC address, or we have a remote leaf that has that VLAN instantiated, we need to know it. We generate those two type 2 routes. We send them to the other leaves. And then because Leaf 4 doesn't have VLAN 10, doesn't do anything with the MAC route. But what it does do is it takes the type 2 route and then populates its layer 3 forwarding table with a /32. So if host 2 wants to send a packet to host 1, it'll come up into the forwarding table and it will see, oh, I've got an address here. I'll send it to Leaf 1 and Leaf 1 will deliver it locally. So that's how it works with, yeah. So, and then, so next, Leaf 4 will send a packet. It will get learned, and then it will also populate its table. Now notice Leaf 1 doesn't have its local /32 because it doesn't need a /32 locally because it knows where it is. Leaf 3 or Leaf 4 has the same thing. It knows where a remote /32 is, but it doesn't need to know what the local ones are. So that's cool. So now when I have a packet, source IP address is 10.1.10.100, destination IP address is 10.1.10.200. We do a lookup, we have a match, and then we can send the packet over. And then the reverse can happen. So we have the local MAC addresses, and then we have the remote IP addresses. That's symmetric IRB. It works. This is how it works in Arista. That's how it works in Cisco and Juniper, etc. So let's take a look at that in action. And we're going to go to our lab environment here. Let's just clean all this up. Terminal. I need a, where's the terminal button? Command center, where's the, I'll have to edit this out. These are all the different things that I did to create all this. There should be a terminal button. There it is. Okay. Hit it. Never mind. All right. So I'm going to go into leaf 1, and I could do show IP BGP summary. So this is going to show me my underlay. The underlays, all of its purpose is to put the loopbacks into the routing table. And if I do show IP route, I can see all these /32s. These are the loopbacks of the leafs and other spines. If I do show BGP EVPN summary, I can see that my overlay is set up. So this is where the different EVPN route types are exchanged. So I'm full of some EVPN route types. If I do show LDP neighbor, I'm connected to host 1 and Ethernet 10 and 11, but I'm just going to use Ethernet 10 here. Show run interface Ethernet 10. It's connected to VLAN 10. If I do show VLAN, I've got VLAN 10 configured locally, and it's configured for VXLAN. So let's see if we see any MAC addresses in VLAN 10. We don't. This is the Anycast gateway. So I'm going to open up another window here, and I'm going to SSH into host 1, show run interface E1. So if I do ping 10.1, 10.1, this should have triggered a MAC learning event, and it did. So that's the MAC address. I was able to change it to that particular MAC address. And if I do show BGP EVPN VXLAN, EVPN route type MAC IP, I can see that I've created those two route types that I told you about, the type 2 routes, the MAC address by itself and the MAC IP. If we go to the spine, I'm going to spine 2 in this case. I do show BGP EVPN route type MAC IP. We see them as well. They come from, this is the AS number for leaf 1. I've got a MAC address and a MAC IP. And then the spines propagate them to the other leafs. So if I go to leaf 4, or go to leaf, let's go to leaf 2. There's nothing connected to leaf 2. Show BGP EVPN route type MAC IP. And we can see that I've got the routes. Now I see them twice. So I see each route twice, and that's because I get them from both spines. So one comes from spine 1, one comes from spine 2. So they show up twice in the table, but that's okay. We can see the route distinguisher tells them they all come from the same place. That's what a route distinguisher does. And if I do show IP route VRF blue, I can see that I've got a /32 for the IP address for host 1, and that gets propagated throughout the fabric. So yeah, so that's that there. Now let's see if I can ping host 2. Well, actually, I'm not going to ping it just yet. So, but I could if it were learned. So that's how the normal operation goes. Actually, let's go ahead and ping host 2. So host 2 is connected to leaf 4. Let's see if leaf 4 is connected. Show run interface E10. It should be connected. So if I go to host 2 and I ping 10.1.21, I can ping my default gateway, and I can now ping 10.1, 10.100, and I can ping across the fabric. Now if I go to leaf 1 or leaf 2, I can see, I now know both hosts. So nothing's plugged into leaf 2. So if I did plug a host into leaf 2, it's got routes /32s to get to either the host connected to leaf 1 or the host connected to leaf 4. So that's cool. And I can do show BGP EVPN route type MAC IP. Now I see 2 sets of MACs for host 1, 2 sets of MAC IP for host 1, 2 sets of MAC for host 2, 2 sets of MAC IP for host 2. This is all normal behavior. This is the way it's supposed to work. So that's cool. Now, where do the type 5 routes come in? We could run into a situation so it's populated tables if we have a silent host. So let's say I want to send a packet from 10.1, 10.100 to 10.1, 2200 on leaf 4. But host 2 hasn't talked. The MAC address has been expired. Something's gone on. It just hasn't been around. It hasn't talked for a while. So the fabric doesn't know where to find host 2. So how do we find it? The packet will come up into the packet will come up into leaf 1's and look it up its 40 table. We don't have an entry for it, and we don't know what to do with it because we don't know where the next hop is for that subnet. So notice I don't have a route for 10.1.20. So let's disable type 5 routes. So I'm going to, there's a little trick here that we can use to disable the advertisements of type 5 routes. Well, you know what? Let's go back. Let's go to the next section here. I'll tell you how it normally happens. So I didn't use any animation here. So what'll happen is host 1 will send a packet. So let's say we've got two routers, router 1, router 2. They both got hosts on it. Host 2 is a silent host. Router 1 doesn't have an ARP entry, doesn't have a MAC address entry for host 2. So how does that happen? Well, it's pretty simple. Packet gets sent up to router. The router doesn't know a host route for host 2, but it knows, I got this backwards. I gotta fix this. So maybe I'll just re-record this because I got it backwards. So this is 20 and this is 10. There we go. So a packet is destined for 10.1.20. We know the next hop. I don't know where the host is. I don't care. I just know where the next hop is, which is 10.1.51. So it sends the packet onto router 2. Router 2 doesn't have an entry for it or an ARP entry for it, so it just ARPs for it. So it says, who has 10.1.20.200? If it finds it, then the packet will get delivered to host 2. If we can't find it, we'll get a undeliverable, undelivered. I can't remember. There's an ICMP message that comes from R2 to R1 saying, I can't find it. So that's what normally happens. But the problem with internally is that if leaf 1 gets a packet for 10.1.20 and I don't have that subnet locally and I don't have a route for it, where do I send it? Because multiple leafs may have that subnet instantiated on it. But this is symmetric IRB. Not every leaf has to have every VLAN or every subnet. So we need a way to transmit that information from the leafs whenever they configure. So when leaf 2 configures 10.1.21 as its Anycast gateway, it's going to generate this type 5 route so that this mistake here. So that should be leaf 4 and leaf 6. Leaf 2. There we go. So that it's going to generate these type 5 routes, which will get populated into leaf 1's table. So now we have an entry, so we know where to send a packet to try to find a host that we don't know about. So what I'm going to do right now is I'm going to go on to the leafs, to leaf 4 in this case, and I'm going to turn off. I'll do leaf 3 and 4 because I think they both have VLAN 20 on them. I'm going to turn off this type 5 route. So we're not going to send those type 5 routes. So the way that we trigger those type 5 routes is, so I'm going to go into leaf 4, router BGP, make this bigger. So I'm making a few mistakes here and I caught a couple errors. I just made this slide deck and I just made this presentation not 20 minutes ago. So this is my first run through it. All right, so if we look under VRF Blue, redistribute connected, that will generate the type 5 routes. So what I'll do is under VRF Blue, no redistribute connected. So that basically turns off all type 5 routes for leaf 4. I'll do it for leaf 3 as well. Let me just check something over here in so now I've disabled it there. And if I go into leaf 1 and I do show IP or show BGP EVPN route type, it's IP prefix. And we're looking for the IPv4. You can see that we generated some for locally for leaf 1 because I have 10.1.10 on leaf 1. And then 10.1.10 is also on leaf 2. So you can see that's the ASN for leaf 2 is 65.102. So leaf 1 and 2, but we're not getting anything from leaf 3 or 4. So if I go to the spine, go to spine 1, show BGP EVPN route type, IP prefix for IPv4. I'm just getting 10.1.10 from leaf 1 and 2. That's all I'm getting. Now leaf 3 and 4, show BGP EVPN route type, IP prefix, IPv4. They get the routes for 10, but they don't have anything for the other subnets. So right now 10.1.10.0 is the only subnet that's having type 5 routes being generated for it. This will become a problem in a second here. So if I go to leaf 1, I do show IP route VRF blue. Now I don't have any way to get to 10.1.20, even though it's in my fabric, even though it's in my VRF. I have no idea how to get to it. So if I go to host 1, I'll just make sure that we don't see, I don't have a host route and I don't have a network route to get to host 2. I'm not going to be able to ping it. So let's try it. Should be able to ping it, but 2200. So I'm getting net unreachable. I have no idea how to get to it. Now, I can get around this in a kind of a tricky way. I mean, this is not really a solution. If I go to host 2 and I ping my default gateway, what that will do is that will trigger a type 2 route. And then on host 1, I can ping it. So it works. So if I go to leaf 1 and I do a show IP route for VRF blue, I have the /32, so I do know where to get to that host. So as long as the fabric knows where that IP address is, that's no problem. But if it doesn't, it has no way to send it out to the other leafs in order to ARP for it. So we call that the silent host problem. So that's what a type 5 route does. So let me go ahead and turn it back on. I'm going to turn all of this back on. So I'll go to leaf 3. And then I'll do redistribute connected. And then I'll do the same thing on leaf 4. Redistribute connected. Now, leaf 1, if I do show IP route VRF blue, not only do I have a host route to get to specifically to host 2, but if I ever need to try to ARP, if I ever need to send a packet, and the fabric doesn't know where that host is, it knows several leafs it can send the packet to, so it can ARP locally. And it doesn't really matter which one it sends it to, because if they all have the same VLAN, it'll ARP and it'll propagate. That ARP packet will get broadcast or flooded throughout the VLAN. So that's what we use it for internally. So what about externally? Let's go back to the PowerPoint deck. So type 5 routes are generated when a leaf connects to an external network and knows the routes to the outside. These routes are propagated by the type 5 route to the other leafs. So I've got a router here, R1, and it's connected into leaf 3. And it's advertising, there's a BGP session, and it's advertising 172.16.0.0, and there's a host on it, 116.0.10. And it connects into leaf 3. Now, if I have a host connected to leaf 3, I know that route because it's in the VRF. The route was learned through BGP through the VRF, 172.16.0.0.12. The next hop is the IP address of the router. So we can send traffic back and forth to any host connected to leaf 3. But look at leaf 1's routing table. It's not there. So with a type 5 route, that's going to go and populate that external routing information into leaf 1's forwarding table. So now we know that 172.16.0.0, we can, all we have to do is if I get a packet on leaf 1 destined for that subnet, that network, it'll just forward it onto leaf 3. Leaf 3 will then forward it to its next hop. So that's what that's the external type 5 route purpose. So let's go ahead and demonstrate that. So we're going to go into leaf 3. And I'm actually going to go into router 1 too. So I've got a router called router 1. Looks like I need to configure it from scratch. That's okay. And we're going to do on leaf 3, we're connected on Ethernet 1. So interface Ethernet 1, I'm going to put an IP address on there, 10.151/31. And then I'll do router BGP 1. I'll just do AS of 1 because why not? Neighbor 10.150, and the remote AS is going to be 65.103. That's the AS number for leaf 3. And I'm going to do interface loopback 99, IP address 172.16.0.10.12, and then router BGP. Address family IPv4, neighbor 10.150 activate, and network 172.16.0. So basically I just said turn on, let's do a BGP session with that address 10.150, which will be, I'll configure on leaf 3. Its remote AS is 65.103, and advertise that subnet into the leaf. So I'll go in and on leaf 3 and config mode, router, BGP. I'm going to turn off that type 5 route again. So VRF blue, no redistribute connected. And then I'm going to do neighbor 10. Oh, I'm sorry. I got to configure the IP address first. So no switch port. IP address is 10.150. I got to put it in VRF blue, so no IP address. Or yeah, there we go. Show IP interface brief 10.150. So ping VRF blue 10.151. So now I can ping the other side. So what I just did is I configured an IP address in R1 and an IP address on leaf 3. They can ping each other. I've already configured BGP on R1. Now I'm just going to configure BGP on leaf 3. So that command would be just neighbor 10.150 remote AS 1. Oh, that's a router BGP under VRF blue. This has to be under VRF blue. Neighbor 10.151 remote AS is 1. And then address family IPv4, and neighbor 10.150 or 10.151 activate. So if I do show IP BGP summary for VRF blue, I'm established and I'm exchanging routes. I'll look on R1, show IP BGP summary. Oh, did I? Yeah, I think it show run section BGP. Yeah, it was wrong IP address. No neighbor 10.151. There we go. So if I do show IP route, I can see that I've learned 10.110 and 10.120 from leaf 3. And I've got 172.16.0 connected directly. If I look on leaf 3, if I do show IP route, VRF blue, I can see that I've got a path to the 172.16 network. I've learned it on leaf 3. But because I turned off the type 5 routes being generated from leaf 3, if I go to leaf 1, show IP route VRF blue, oh, I do have it there. So it got distributed. So why did it get distributed? I thought I turned that off. But anyway, so on host 1 or even host 2, I can ping 172.16.0.10. There we go. So why did it show IP BGP summary, show BGP EVPN route type, IP prefix, IPv4. Yeah, so we generated it. Oh, it got generated on leaf 4. No, that's something else. Yeah, no, yeah, it's. Oh, it got populated. Oh, what I need to do is I need to go to leaf 4 and do it. Show IP route VRF blue. I see it there. Show IP BGP route type. Show BGP EVPN route type, IP prefix, IPv4. It's hard to read these tables with the font so big. So I got it from it came from 3. Oh, maybe I didn't turn. Yeah, that's not a way to yeah, there's a different way to turn off the Type 5 routes, and I don't know what it is. Anyway, I was trying to demonstrate it not doing the Type 5 routes, but it did anyway. So let me do go back into leaf 3. Show run section BGP. Just make sure I did it the way I think I did it. Yeah, so there's VRF blue. There's no redistribute connected. Oh, that should do it. That should turn it off. No, it didn't turn it off. Yeah, still didn't turn it off. Maybe it's no redistribute. Yeah, there's a way to turn it off. Or there should be a way to turn it off. Not everything goes to plan. Oh, it's in there. No redistribute. Connected, dynamic. I could just do no redistribute BGP. That should turn it off. Yeah, that would turn it off. Nope, didn't turn it off. Oh, it didn't take. Maybe that was a default. Yeah, it's default. Huh. You learn something new every day. Anyway, that'll do it for this video. I'm probably going to re-record this just because ran into a couple snafus and stuff. But I've demonstrated why Type 5 routes are needed. The only thing I couldn't figure out was how to not distribute an externally learned Type 5 route. There must be a way to not do that, but I can't think of what it is. The other weird thing was I was seeing show show BGP EVPN summer route type IP prefix IPv4. Yeah, I'm just seeing it from leaf 3. I'm not seeing 20 from leaf 3 either, even though it's configured there because I did that thing. So the external routed stuff, that's interesting that it distributes it even though I don't have redistribute connected. That was not the behavior I expected. So I'll play around more with that and maybe just re-record this. But anyway, I hope you found this useful. If you have any questions, respond in the comment section below. I do read them and I